To see how, imagine a clock is being sucked into it. As the clock gets closer and closer to the black hole, it begins to get slower and slower. Time itself begins to slow down. Now, imagine the clock as it enters the black hole, it would actually stop. It stops not because it is broken, but because inside the black hole, time itself doesn't exist. These are the words of late theoretical physicist Dr. Stephen Hawking. But can a black hole really stop time? Welcome to Fact Nominal, and let's find out if black holes are powerful enough to stop time. An experiment for the times. Imagine you and your friend are super space science stalwarts who decided to test the theory of Dr. Stephen Hawking, who proclaimed that inside a black hole all clocks will come to an absolute stop. Vis-a-vis, time will cease to exist when you are in the singularity of the black hole. As you and your friend observe the approaching black hole's event horizon from the window of your spaceship, you two decide to synchronize your watches. These are no ordinary watches, mind you. They both carry a radio signal which on reaching the other watch causes a beeping sound. As you two sync your watch, you can hear both watches beeping at the same time at an interval of a second. Your friend smiles as he looks at you. This is the final goodbye, as you have no idea if he will return or not. Correction, could he return or not? For your friend has decided to test the time-stopping power of the black hole by himself, a place with theoretically no return. He is going to travel inside the black hole so you can record the time dilation between two watches. As your friend leaves in his escape pod towards the event horizon, you can tell the watches are still in sync. The second needle moves with the beeping sound coming from the radio signal from your friend's watch. But after a while, you start noticing the lag in the beeps. They have begun to fall behind the second hand of your watch. As you try to locate your friend's pod in space, the beeping reduces to once every 2 seconds. Worried for your friend, you peek outside the window pane of the ship and see your friend's pod in the huge distance approaching the photon sphere of the black hole. The pod looks like a dot now, the beeping reduced to once per 5 seconds. As the pod gets closer and closer to the event horizon, the beeping drops drastically, first occurring once per minute, then 10 minutes, then 20, an hour, and sooner maybe more. After a week, when your watch beeps again, you realize it has been so long since the watch beeped last time. And before you know it, you decide to return home because now it's been over a year since you have been waiting for the watch's next beep. Does that mean that time has become so slow for your friend that a second is like a year for him now, and eventually it will stop moving at all and your watch will never beep again? How black holes warp time and space. Black holes are true holes in space. With physics so crazy and mind-boggling, we still aren't exactly sure what goes down inside it. But we do know that the black in the black hole is the darkest black in the universe. If you shine a light on a black hole, it won't bounce back. The hole would just swallow it like it swallows everything else. This is why black holes are considered the edge of the universe, a one-way exit with no chance of a return ticket. The gravitational pull of a black hole not only affects space, but also time. As your friend's pod gets closer and closer to the black hole, as an observer, it will slow down for you. Near a black hole, the slowing of time is extreme. From the viewpoint of an observer outside the black hole, time stops. For you watching your friend enter the black hole, it would figuratively never happen. You will see them stuck at the edge of it, frozen in time. But for your friend, time will still be moving if we hypothesize that the immense gravity of the black hole hadn't crushed it. Their watch is still ticking every second as they cross the event horizon, and their path will bend and warp as space and time will warp around them. But because they are on the same path as space and time, they won't feel a difference. Time will be moving for them as well. Stay with me, there's more to it. From outside the event horizon, the infalling entity would see the outside universe as well as the blackness of the event horizon, which grows larger and larger as they approach it. But once they cross the event horizon, something funny happens. No matter which direction they move or accelerate in, no matter how quickly or how powerfully they do so, they will always inevitably find themselves headed towards a central singularity. There is no escape. The singularity can be a zero-dimensional point if the black hole is stationary, or a one-dimensional ring if the black hole is rotating. One cannot avoid the singularity once the event horizon is crossed.